Hello, and welcome to today's daily Leetcode challenge. Let's begin question 1318. Number flips to make an A or B equal to C. So the A or B, this is a bitwise operation, equal to C. Given three positive numbers, A, B, and C, return the minimum flips required in some bits of A and B to make A bitwise OR B equal to C. Bitwise OR operation. Okay. Flip operation consists of change any single bit 1 to 0 or 0 to 1 in the binary representation. Okay. So let's look at some examples, but pretty much what's given to us are three numbers, and if we were to do A or B, we would get another number. We have to have that number, the A or B, be equal to C, and figure out how many flips to and where to have those flips. An example here, we have a 2 and we have a 6 given to us. A is equal to 2, B is equal to 6. The result has to be a 5, however. If we were to do bitwise operation on this, or we would actually just have 6. Nothing would have changed. But we need 5. And let's see, why is the answer here? Oh, it's 3 because we need to have, okay, let's look at this a bit more closely. This is a 2, A is here is a 2, B here is a 6. If we were to do the OR operation on A and B as they are given to us, we would have had 6. Nothing would have changed. That is because the rightmost column of zeros would have still been a 0, the second would have been a 1, the third would have been a 1, the fourth would have been a 0, and we would have had 0, 1, 1, 0 as a result here. What we need to have is we need the first one to be equal to 1, so that would have been equivalent of us either changing one of these zeros to a 1. The second column has to be a 0, so both of these have to be equal to 0. The third has to be a 1, and we can leave that unchanged, and hence we're changing 3 bits. All right. I think we could start implementing this. For those of you who may not be familiar with bit operations, you can convert any bin. You can convert any number to a binary simply by casting it into a binary here. Oh, and I should probably print these. I just wanted to show. Oh, this is pretty trivial, but could be interesting to see. Print, I can spell. But here we have these numbers exactly how they are appearing here in the example, with one exception. We can see that the binary numbers are not pre-filled with zeros to the left. The first 2 characters here indicate that this is of type binary, and then the rest are a non-pre-filled consecutive characters, zeros and ones. So right here, it would be good for us to have them all line up, since we want these columns to essentially be aligned. How we could accomplish this is by doing an AND operation on each one of these integers in binary format with 1. Here's what I mean. Let's say that while A is greater than 0 or B is greater than 0, we already had, let's say A binary is equal to A and 1. Let's have B, C. I'm going to show you what I'm doing right here. Print A binary, B. Let's print B binary and C binary. What we should be getting here is, without this while loop for now, is we should be getting the first column here right away. So 0, 0, 1. And let's see if we get 0, 0, 1. Standard out, C bin. I didn't define that. C bin. 0, 0, 1 once again. 0, 0, 1. That just means that we got the first column. A clever trick to essentially loop through all of these characters column by column, starting with the rightmost one and ending with the last one on the left, would be to also do shifting. So a way you would do a right shift, which is essentially dividing by 2, or shifting all of the bits, shifting this decimal point, if there was one here, to the left, shifting right. So a little bit confusing, but you could do it this way: B and C, 1. And I got a little bit ahead, and I also have this everything in a while loop. The reason for that is as we're shifting to the right more and more and more, eventually the number that we're looking at will become a 0. So shifted A as it's provided to us twice, after shifting it to the right twice, we would get a 0, because after the first shift we would get a 1, after the second shift we would get a 0. So what we're going to see right now is a print out of, let's see, is this? Okay. The first 3 are the first column, 0, 0, 1. The second 3 should be the second column, 1, 1, 0. And the third column should be 0, 1, 1, 0, 1, 1. There we go. So at this point, we have all the columns printed from right to left, one by one. And the rest is pretty easy. Let's define a variable called flips and simply start our condition for incrementing flips. If CB is equal to 0, then we know that both A and B have to be equal to 0. So that would be flip plus equals, and let's say AB plus BB. Pretty straightforward. The OR operation is basically, the truth table of an OR operation is, how would I do this? A, B, and then this would, I mean, I don't know if this is worth doing, but maybe it is. 0, 1, 1, 0, 1, 1, and the truth table here would be that C, and this is a 0, 1, 1, 1. That's what the truth table looks like. So else, if it's a 0, then we would simply if it's a 1, then we would have, if it's a 1 and both A, B is equal to 0 and B, B is equal to 0, then we would have flip plus equals 1. And let me have this at the top. Finally, we would return flips, let's call it flips instead. Save this guy here, maybe for reference, flips. All right, let's run this. But it should be pretty intuitive. Flips is the variable that keeps track of number of flips to make. A and B and C you already know, but this condition here, I'm simply checking what are the different scenarios in which I would add to flips. I would add to flips if both if C is a 0, in which case if it's a 0, I would need to flip both A and B in the case that they are already equal to 1. So I simply add AB and BB together, indicating how many 1s there are. If there's 0, then that would just be 0. And then add them to flips. In the contrary, if C is equal to 1, all I need to do, 1 is pretty much guaranteed to us unless A and B are both equal to 0. So if AB and BB are equal to 0, then add 1 to flips, flipping either one of them. Let's submit this. This should work. And let's see, are there any faster, better solutions? Res. And no, I would say that this is also fine as usual. In terms of memory, we don't really care, but pretty intuitive. Still nothing too crazy. These are just bitwise operation problems, and I'm assuming that we're going to be getting a bunch soon, but feel free to use this, and thank you for watching. Please like and subscribe. Bye.